Hello and welcome to the EMC Live webinar, HEMP and IEMI threats, specifics on how to protect critical infrastructure systems with specialized shielding. My name is Belinda Stashukevich and I'm the editor of Interference Technology, the creator of EMC Live. EMC Live is a brand new online 3-day event featuring practical information and topics. This event will include roundtables, webinars, and videos on everything EMC related, and there's no cost to attend. Join us for our other webinars this week. This webinar is presented by Michael Caruso, Director of Government and Specialty Business Development for ETS Lindgren. Mike is a recognized leader in the RF shielded enclosure anechoic chamber industry with 30 years experience in account management, project management, technical applications, business development, marketing, and sales planning. Mike chairs ETS Lindgren's HEMP and EMP product team and has been involved in a sales, design, engineering, and project management capacity for hundreds of projects involving high-performance RF shielding. Mike led the EMC Power Electronics testing program for the Boeing 787-8 while at the Ingenium Testing Laboratory. This webinar is sponsored by ETS Lindgren. ETS Lindgren is an innovator of systems and components for the detection, measurement, and management of electromagnetic, magnetic, and acoustic energy. They adapt new technologies and apply proven engineering principles to create value-added solutions for their customers. This webinar is one of many. To check out our others, visit emclive2014.com. A recording of this webinar and downloadable PDFs will be available on our website shortly. This webinar will be interactive. You will be able to ask questions, and we encourage you to participate. Take a look at your GoToWebinar navigation pane. If at any time you have a question, we ask you to fill out the type box and hit send. To make the screen minimize and maximize, click the arrow button. To raise your hand to ask a question or report an issue, click the hand icon. We will present the topic for 35 minutes, followed by a 10-minute question and answer session. Now Michael will begin the presentation.
Thank you very much, and welcome to everyone. I appreciate you attending this webinar. And what we are going to cover today is looking at how high altitude electromagnetic pulse and intentional electromagnetic interference will pose a threat to the critical infrastructure and some of the mitigation techniques that might be used to combat it. Just to start off, we'll look at some of the terminology. EMP is an umbrella term that is used quite often to identify high-level electromagnetic energy. In the case of this presentation, we're going to use EMP as an umbrella term to cover high-altitude electromagnetic pulse. That's looking at pulses from an outer space detonation of a nuclear device 18 miles high or higher, and also intentional electromagnetic interference, IEMI, and that's from intentional electromagnetic weapons. And we will talk more about that as we go on. With an EMP threat, it's important to remember that every electronic device is at risk. And one of the very important things is that, unlike a cyber attack where you would have fingerprints of events that might disrupt your equipment or your data, the IEMI attack will not leave any information behind, and it is so rapid that the recorder will not record the event. So how much EMP is really needed to destroy your device? Well, in the industry, as I'm sure many of you know, we measure susceptibility or immunity to electromagnetic waves in volts per meter. And just to remember that most electronic equipment out there can survive the 10 volts per meter, but an EMP creates a pulse that is higher than 10,000 volts per meter, and in some cases up to 50,000 volts per meter. As a reminder, the harmonized immunity standards that we've worked with in the EMC world, here are some of the levels that are tested. And off-the-shelf IT equipment, you're looking at 10 volts per meter is the test limit. and moving on down the line just to military equipment at 200 volts per meter. As you can quickly see, it's a far cry from the 10,000 to 50,000 volts per meter that might be emitted from an HEMP or an IEMI weapon. Looking at the EMP threat, this is a non-classified electronic weapon electromagnetic weapon that is being produced by Boeing, and it was declassified, and it's the Boeing CHAMP, and it basically is a cruise missile-like device that flies around, can be programmed for specific targets, but it emits high-powered electromagnetic waves rather than explosions. So it does not detonate, it doesn't explode, it doesn't kill anyone, it doesn't damage any equipment except the electronic equipment that might be in a building or a cluster of building that it targets. This is a photograph of an IEMI weapon that could be constructed in the back of a pickup truck. You might immediately see that the pickup truck is not a late model pickup truck, and that's because it's been hardened, and the newer models are more susceptible to an IEMI. But this device could potentially reach levels of 50,000 volts per meter, and what you're looking at would have a range of some 300 yards to its target. So driving by a building, street level, it would take out a building, or certainly take out the elements of an entire city block. There are also suitcase devices that are available. This one happens to be manufactured by Diehl out of Germany, but these devices, they can't produce fields that are high enough to be damaging to equipment, but certainly very disruptive. So if someone were to enter a facility with one of these devices, it would definitely interrupt and disrupt the data processing elements and all of the electronics that are going on in the building. Looking at some of the various threats to the system types, on the power grid, EMP is particularly harmful to the power grid with the E1 and E3 threats, and also the IEMI RF weapons for control systems on the grid. And as you look down the chart here, you've got different systems. It's important to look at especially the vehicles, ships, and aircraft. While many people will consider hardening their facility, they're not thinking about the vehicles that they might need to employ in a response mode should there be some sort of event that they have to respond to. One of the specifications, the primary specification that has been used for hardening of military and government installations is MIL Standard 188-125. And this specification has been around for a while, and it's intended to support and protect time-urgent command and control centers, C4I functions. The specification itself requires a lot of items that are perhaps not necessary for protecting infrastructure facilities, such as the 188-125 does require that the system, the shielding system, be an all-welded system. And what we have found is that certainly for protecting non-military, non-C4I functions, a modular system that has been tested and certified to meet the performance levels of 188-25 is very acceptable. Interestingly enough, the critical infrastructure elements that are most interested right now are the electrical utility segment, the financial segment, and a bit of the medical segment. But with the electrical utility segment, it's gotten a lot of publicity because the state of Maine last year actually enacted legislation requiring the public utilities, the electric utility, to address the issue of IEMI, HEMP, and geomagnetic disturbances. And for the sake of this presentation, we're not going to address geomagnetic disturbances. That is a whole different subject area that would require a different approach for protection. As a corollary to that, there has been a House Bill 3410 introduced in U.S. Congress, and it's a bill to amend the Homeland Security Act and require Homeland Security to oversee the protection of the power grid and work with the power grid providers in order to do that. That bill is currently in committee, and we're hoping that it gets voted on sometime very soon. Just a review of one of the things that are just absolutely critical to protecting the infrastructure would be the data centers. We rely heavily on data centers these days, and in accordance with the Uptime Institute, we're looking at some of the requirements for data centers. The Tier 1 data centers, as an example, are allowed 28.8 hours downtime per year. And these are data centers that would not typically be supporting critical infrastructure. Likewise, the Tier 2 data centers have a requirement of 22 hours of downtime per year, no more than. And again, the Tier 2 data centers would not be supporting critical infrastructure. But when we get to the Tier 3 data centers with a maximum of 1.6 hours of downtime per year, and the Tier 4 data centers with a maximum of 2.4 minutes per year, these are the data centers that we are finding are very concerned about including HEMP and IEMI protection in the overall scope of the protection that they're evaluating for disaster recovery and disaster resiliency. It's important that when we're looking at a facility, we look very carefully at the mission of the facility and determine exactly what needs to be up and running 100% of the time, what outage might be acceptable, and what equipment might be able to be sacrificed during an electromagnetic event. With the EMP event, it's also important to determine the extent of damage to critical long lead items, such as, if your backup generators are damaged, it's several months to get a replacement and get yourself back up and running. So generators are something you might want to consider protecting in the event of looking at a run-through environment. What we tend to look at ETS Lindgren is two levels of protection. Protection level 1, as we call it, is survival of data and equipment. And that's protecting the critical equipment with a shielded environment, and all points of entry are addressed. In this scenario, the data center itself might go down during an event. The power systems might be lost, the cooling systems might be lost, but all of the equipment located within the protected EMP environment would be safe and be able to be restarted once the utilities and cooling are restored. And this is an example of a standalone shielded EMP enclosure that might be residing within a building. So it is standalone. It's reliant upon the parent facility for all of its utilities. What we look at secondly is what we call level 2, and that's survival and continuous operations of data and equipment. And in this scenario, if an EMP event does occur, the utilities will continue running. So the cooling systems are protected, the backup power is protected, the UPS systems, and any other support functions necessary to keep the data center running. And this is an example of that same protected environment within the data center facility, although you do see that it's connected to an outdoor facility that would house the generator and the cooling towers and chillers for the cooling systems. These are photographs of some of the basic shielded enclosure designs. To the left, we see the welded enclosure, and that's made up of a steel plate, minimum of 3/16 inch thick and sometimes thicker, with continuous seam welding in all directions. On the right, we look at a modular system, and this is a bolt-together modular system that is brought to the site and assembled in place. Some of the doors that get used on various HEMP protected facilities, and the door on the far left and the door on the far right are doors that are more commonly used in military applications. The door in the center, which is a recessed contact mechanism type door with beryllium copper fingers and a brass extrusion around its contacting edge, is the most common type of door that gets used in facilities that would be protecting the critical infrastructure elements. What we're looking at in this photograph are power line filters. The photograph to the left is showing a cluster of 4 1200 amp units that are making up power entry to this facility. So that's a 4800 amp power entry component that you're looking at. And power and signal line filters are available. Might add that these types of filters for EMP protection must be inductive input type filters with surge arresting devices on them. Most commonly MOV devices, metal oxide varistors. The photograph to the left here is showing a complement of waveguide air vents that would be used for entry of air into a shielded facility. And to the right, we have waveguide penetrations. A bit of a misnomer because they are waveguide beyond cutoff, and that's the designation of them. And remembering with EMP, we're looking at 1 gigahertz as a top frequency. And now I'm going to go through a series of photographs showing the installation of a large shielded HEMP shielded facility. And here what you're seeing is a 20-foot tall facility, and there's pieces of the ceiling going in to establish the protection. In this photograph, we have the mechanical room, and I might call your attention to the floor of the mechanical room. In this floor, this is a welded floor. The seams are continuously full penetration welded, and that's because of the nature of the building itself. In a mechanical room, you're going to get spillage, you're going to get various fluids that might wind up on the floor, you've got equipment being moved in and out, so you need something a little bit more robust on the floor than the modular shielding. Call your attention to the ceiling in this room, and in the ceiling of this room is the modular system. So the floor of this area is welded, and the walls and ceiling are modular system. What we're looking at here is a double door vestibule. You'll see the shielded doors prominently in the foreground, but if you look towards the rear, you'll see another set of doors. You'll see the door jambs there. And this is creating an interlock vestibule for entry into the shielded area. the vestibule is used so that at no time is the inner protected volume susceptible to an attack or anything that might be happening outside the volume. What we have here is an example of a prefabricated mobile shelter that would house a backup generator. And these things are prefabricated in various sizes. They can be quite large, actually, and be brought to the site, set on a concrete pad just outside of the building, and then connected with RF conduit back into the building to provide the backup power. And it might be best to note that if in fact in a facility they chose to go with a protection level 1 and not a continuous operation, the continuous operation mode can be added later on simply by bringing one of these shelters in, setting it on a concrete pad, and piping it into the existing level 1 shelter, turning the system into a level 2 design. And again, back to a rendering showing an outdoor shelter, prefabricated shelter, piped into the inner shielded volume of the data center. A lot of the verification testing that goes on for HEMP IEMI protection, some of the special testing that goes on is pulse current injection testing. And this is where very large currents and voltages are directly injected into the conductors that are passing through the filter elements, and the measurements are made on the load side of the filter elements. So on the line side they get injected. In order to pass the limit with a 2500 amp injection, you can only let through less than 10 amps on the load side of the filter. So it's very important to make sure that you've got certified filters that you're using in the facility for your protection. And the verification testing that goes on for the shield itself is the quite common shielded effectiveness testing that is prescribed by IEEE 199, where you establish a dynamic range between a transmit and receive antenna, and then take those two elements, put one inside the shielded enclosure and one outside, and measure the reduction in the transmitted and received strength of the waves. This is an example of an overlay of 8 various points that might have been tested on a shielded enclosure. The red line is showing the limits of the 188/125, and the other lines are showing actual measurements from the 8 points that were measured on the shielded enclosure. As you can see, it's well within the limits, and this would be a very successful shielded enclosure for EMP applications. So in conclusion, what we're looking at here is that critical infrastructure facilities that support our way of life and our living are actually designated by Department of Homeland Security. There are 16 critical infrastructures identified, and you know, they have become a significant part of the survival of our way of life. Both narrowband and wideband EMP waveforms can be produced by the non-lethal weapons. An HEMP would be a broadband only, but the IEMI weapons can also produce a very targeted narrowband threat if they're built accordingly. all modern electronics are extremely vulnerable to EMP because of the nature of electronics getting more compact and smaller every day, operating at smaller voltages. And you know, a 50,000 volt per meter signal with a non-classified 10 nanosecond rise time and a 15 nanosecond fall would really destroy any electronics that are in its path. The protection measures are available, and we've gone over some of them here. But what's happening is that many businesses that are in the business of supporting critical infrastructure are not aware of the threat. Over the past few years, what I've seen is an increasing interest in looking at the threat of electromagnetics, and more so IEMI than the HEMP. Many people believe that HEMP protection is something that the government should be looking out for, but the IEMI protection is something that looks like it can be a threat, and a threat from not only criminals but terrorist organizations as well. And as I go around and I speak to various groups, there is a prevailing statement that comes back, and it says, you know, it can't happen. Well, there are instances where it has happened, and we certainly do believe that it's something that warrants addressing, and addressing the protection that might be available to protect ourselves. So I've tried to make sure that I come in with plenty of time for questions if there are any. So at this point I can ask Belinda to come back on, and we'll address any questions that might come up. I thank you very much for listening and attending this webinar, and certainly if you have any questions or interest in discussing any of this further, feel free to contact me directly.
Great. Thank you so much, Mike. We have a few questions coming in, and we encourage everybody to send even more. We have one that asks, what is the frequency of 10 volts per meter limit for electronic equipment survival?
The frequency ranges that are looked at in the harmonized IEC standards are 30 megahertz to 10 gigahertz.
Okay. Does the construction foundation rebar require surge suppression filtering?
The rebar itself would not, but remembering that the shielded enclosure is a six-sided enclosure. So many times when a modern building is constructed, the rebar system does get incorporated into the ground system. But when looking at an EMP protected facility, it's important to remember that we're talking about a high frequency ground. So it would in most cases be a supplemental ground to the 60 hertz safety ground that the building relies on for its power system.
Okay, another question. Certification-wise, how do you generate the fields necessary to certify critical infrastructure shielding? Also, during the certification tests, how do you protect measurement equipment and other equipment from unintentional damage?
Yes, well, ETS itself does not have that equipment. There are actually very few labs in the world that have that equipment. We rely upon Little Mountain Test Facility, which is a U.S. government facility at Ogden Air Force Base, Hill Air Force Base in Ogden, Utah, and it is run by under contract with Boeing to do all of the EMP testing for the government. They've got very specialized equipment that's built and hardened so the equipment doesn't destroy itself. And it's very, very expensive and very specialized equipment that they have. And if you need to know more about that equipment, I would suggest contacting Little Mountain Test Facility.
Great. Here's another question. What's the shielding effectiveness of enclosure on level 1 and 2 protection?
Shielding effectiveness would be, in accordance with MIL standard 188-125, it is 80 dB at 1 gigahertz.
Okay, we have another question. I'm not sure if you can clarify on this. Someone asked, can you provide examples of IEMI facts?
The attacks that have been perpetrated are not well documented out in the public domain, but there was an instance in Europe where a financial institution, actually a manufacturing organization, a large company, was targeted by criminals. They went in and the criminal element purchased a bunch of the stock for the company, and they purchased it short. They ran an attack on the company, and the company went black for several weeks because of the attack. Their stock tanked, and the criminal element sold short and made a bunch of money on it, but they were caught. It's difficult to find documented cases of IEMI attacks because the bulk of them have been perpetrated on financial institutions, and the financial institutions are not happy to share that information.
Great. Here's another question. How do you certify a whole building without damaging adjacent buildings?
Yes, with that, we do standard shielding effectiveness testing, and those power levels are at a level that are well within the FCC limits and doesn't damage the other buildings. When the pulse current injection testing is done on the building, they isolate it from the power grid, so the power is shut off to the building, and the pulse injection happens from the line side of the service entrance on in. So no other facilities in the area are affected by it.
Great. Just wanted to have a call for any other questions. We have a little bit of time left, and everybody has been very attentive, but we need a few more. Oh, here we got one. What is the maximum diameter for the cutoff frequency for metal pipes that are carrying glycol into the hemp protected area at 1 gigahertz?
At 1 gigahertz, the formula for looking at waveguide beyond cutoff is typically looking at the maximum diameter being less than 1/2 wavelength. We have standardized based upon experience and the counsel of Dr. William Radasky. We've standardized on 3.5 inches being the maximum opening that we allow, and we've been very successful in building facilities with that in mind. If you looked at the formula by itself, you could go up to 4 or even perhaps 4.5 inch maximum opening for achieving waveguide beyond cutoff, provided you maintain the six times the maximum opening in the length of that waveguide beyond cutoff. But again, we have standardized on 3.5 inches, allowing for a safety factor. And when you're working on an entire building, we really would much rather be safe than sorry.
Great, thank you, Mike. We have a couple more.
You're welcome.
During the project of a critical building shielding, do you consider the possibility of an attack from inside the building?
The facilities that we have done are generally in high security areas, and these are non-government facilities that I'm talking about. So be it financial institutions or the electric utilities that we've seen most of the activity with, these are high security buildings, and it's treated as a government facility. So we look at entry and exit very carefully, keeping track of who's in and who's out. And so I guess the short answer is, we've not seen any attacks, and it's not something that we pay a lot of attention to because of the inherent security profiles of the facilities where we work.
Okay. What will be an ultimate protection that will provide protection in full spectrum from 1 hertz to 10 gigahertz?
Oh my gosh. 1 hertz is something that's going to be very, very difficult to protect, and it depends upon the levels that you want to protect. In general, you're looking at HEMP protection beginning at 20 megahertz, 20 kilohertz and up. For 1 hertz, you'd have to rely very heavily on very thick metal, so it would be a welded facility. It would be very thick metal to address the magnetic field component.
Okay, great. If we have any more questions, we need them now. Otherwise, if you do have any in the future, you can send them to info@emclive2014.com, and we will respond to you accordingly. We received quite a few inquiries on where to get additional information on this topic. There's a vast amount of content found on our website and also at interferencetechnology.com. Please join us for EMC Live 2015, which takes place April 28th to 30th. Webinar attendees, if you have any more questions we didn't answer, please send us an email at info@emclive2014.com. Recording of this webinar will be available. We will also send a link to all participants shortly. Thank you for attending.